More than 30 times the distance from the Sun, almost at the edge of our solar system, is mysterious planet, Neptune. Without a telescope, it is impossible to see even from the highest points on Earth. Because of its distance, Neptune is the least studied planet in our entire system, but what can be so mysterious about this planet? Would you be surprised if we told you that Neptune, one of the coldest planets in the system, could support an ocean of superhot water? Today you'll learn about that, as well as Neptune's strange rings that make it so blue, and what is now known about its famous satellite, Triton Neptune. Neptune is an ice giant about 4 times the size of Earth's width. It has a radius of about 15,300 miles and a volume of 15 trillion cubic miles, which makes Neptune 58 times the volume of the Earth. The planet is mainly composed of water, methane and ammonia. Like other ice and gas giants in our system, Neptune has no solid surface. Its atmosphere extends deep into the planet's mantle, which consists of methane and ammonia ice and a rocky core. However, scientists believe that the ice giant could theoretically have an internal warm ocean temperature, but how can a planet support such an ocean, since it is so far from the Sun? In sunlight, the giant took 4 hours to reach the surface. Neptune's average atmospheric temperature is -360 degrees Fahrenheit, making it one of the coldest objects in the solar system. In addition, recent studies show that most of Neptune cooled between 2003 and 2018, despite warming near the South Pole between 2018 and 2020, likely due to seasonal variations in atmospheric chemistry. The probable cause of the formation of the ice giant ocean is still unresolved. However, scientists suggest that this oddity can be explained by internal heating, heat released by gravitational compression, or the gravitational interaction between Neptune and one of its satellites, Triton. On the other hand, scientists Sloan Viktorovich and Andrew Ingersoll believe that the chance of oceans on Neptune due to its heat is very low, currently only 15%. According to scientific calculations, in just 1 billion years, the probability of an ocean will increase by up to 40% as the giant cools. Another explanation for the enormous internal energy could be the collision of Neptune with some cosmic object, because Neptune is the only planet that emits almost 3 times more energy than it receives. From the Sun, this is also confirmed by the unusual tilt axis of 28 degrees, which is almost the same as on Earth. That's why Neptune also has seasons similar to ours, but one season on Neptune lasts about 40 years. 1 year on Neptune is 165 Earth years, but 1 day on the ice giant lasts 16 hours. This rapid rotation of the planet creates a very strong wind, which we will talk about a little later. Neptune's atmosphere is 80% hydrogen. It also contains 19% helium and about 1% other gases, including methane. Moreover, Neptune's blue color is due to methane clouds in the upper atmosphere. Methane molecules can absorb the shortwave radiation from the Sun, reflecting a blue color. However, Uranus, the planet closest to Neptune, also contains a similar gas distribution, but unlike Neptune, its color is light blue. Dr. Patrick Irwin of the University of Oxford suggests that this color difference may be due to the density of the methane nebula, **4:16-5:12**. So both planets have several layers of aerosols in their atmospheres. The lowest deep layer consists of a mixture of hydrogen sulfides. Thanks to this layer you can see some regions closer to the poles, for example on Neptune they appear darker. The second layer is apparently the one that affects the colors of the planets. It is a layer of fog particles where methane ice is likely to form. The ice then precipitates as methane snow. Because Neptune's atmosphere is much more active than Uranus's, Neptune forms this snow more efficiently, causing its second aerosol layer to be thinner. This rich blue color is caused by the lower density. The last third layer of the atmosphere also forms large methane ice particles and is actually an extension of the second layer, **5:13-5:57**. Storms. In addition to the intense color, Neptune's surface is also characterized by dark and white spots. All these points are storms caused by the very fast axial rotation of the planet. Neptune is the windiest planet in the system. Wind currents can reach 1,200 miles per hour, nearly 4 times stronger than Jupiter. However, the ice giant has one thing in common with Jupiter, a massive storm. The name of this vortex is quite simple, the Great Dark Spot. The Earth-sized cyclone, spinning at 1,500 miles per hour, was first spotted by the Voyager 2 spacecraft in 1989. However, in 1994 another telescope, Hubble, noticed that the spot had disappeared and a small new spot had appeared in the northern hemisphere. **5:58-6:38** Unlike Jupiter's 300-year cyclone, Neptune's large-scale eddies only exist for 2 to 6 years. In 2018, Hubble discovered another new location similar to the one discovered in 1989. The origin of these storms is not yet known, but scientists suggest that they originate deep in the atmosphere and occur over many years. These storms still have something to show scientists. The new 2018 location began drifting south the following year, where it would disappear. However, to the scientists' surprise, the storm turned and began to move back north. Also, the small is apparently separated from the large, *6:39-7:05**. NASA scientists believe that the small vortex may be part of a large storm breakup process that has never been observed before. In previous observations, such cyclones were followed by white clouds of methane called thrusters, because the speed of movement is greater than that of the large patch. They probably form on top of eddies, where gases freeze into ice crystals. Scientists say the lack of clouds can help understand the formation of Neptune and similar ice giant blobs, **7:06-8:03**. Music, chords like other gas giants. Neptune also has another feature, the sound system. In 2022, the James Webb Space Telescope captured a near-infrared image of the ice giant, revealing its faint rings and satellites. The last image of Neptune's rings was taken by Voyager 2 more than 30 years ago. Webb's new photo shows about 5 rings. All the rings are named after the astronomers who participated in the study of Neptune. The closest and loosest ring is called Galle. Composed of approximately 40 to 70% dust, it is 26,000 miles across and has a radial width of 1,240 miles. The second ring, Verrier, is much brighter but much narrower. It is just over 62 miles wide, **8.04, 9.00**. The next circle is the widest, this is the Lassell Circle, 2,485 miles wide. The percentage of dust there is very small, varying from 20% to 40%. The fourth ring of Arago is hard to see. It is one of the smaller rings, with a radius of 35,540 miles, located on the Lassell rim, and probably barely noticeable due to its low dust content. The radius of the last Adam's ring orbit is approximately 39,724 miles. In addition, Adams is only 35 kilometers wide, making it the narrowest ring on Neptune, **9:01-10:02**. Satellites. But what sets this tire apart are its curves. Arcs are mysterious bright segments of dust around the circumference of the ring. Each Adams arch has a name: liberty, equality, fraternity, and courage. Interestingly, they are not stationary at all. These bows, especially brotherhood and equality, change their material and change their size. Why these arcs formed is not yet known, but researcher Emke de Pater speculates that the collapse of the parent companion or another object within the Roche limit may be the cause. In addition to the rings, Webb also captured 7 of Neptune's 14 moons. All ice giant moons are divided into regular and irregular. Webb imaged 6 ordinary inner satellites. Some of these satellites, such as Despina and Galatea, form Neptune's rings, acting as dust collectors, **10.03-11.03**. However, the most interesting feature of the Webb image is by far the most distant bright satellite.